Hi friends, today we want to look at another classwork that will help us very well in our training of how to design, install and repair and maintenance of solar system. And this particular point is very critical, most especially this area when it comes to designing the size of the inverter. That is the size of the inverter you need. For example, if whether you need 1 kVA, need 2 kVA, you need 3 kVA, you need 5 kVA, you need 10 kVA, as the case may be. This particular classwork, you watch it to the end and have a proper knowledge on how to calculate your real-time load and how to balance it to get your real size of inverter. Now, I read the question. Design an inverter system that can handle or carry the load of 2000 watts using the power factor of 0.8. State the size of the inverter needed, and it must be what? 48 volts. At this point, you look at it, you know whether what you are calculating is right or wrong. And that is why the power factor has to be stated in this place. As we move forward, you will know what it means by power factor. Power factor is very important when it comes to electrical system. So watch the video to the end as we go for the solution now. Solution. We want to gather the informations. That will give us the 2000 watts. Number one is ceiling fan. We'll tabulate it as you can see it now, so that it will be very easy for us. If you have been following us on this channel, you realize that most of our examples on how to calculate the load, we tabulate it to make it easy for the learners to understand. And that is why we are looking at it this particular hour to get the right thing. We are still using a tabular form to get our data. Solution. At the solution. Now, we are gathering the item at this moment. Solution number one is our serial number, the items, quantity, unit wattage, and total wattage. So number one is ceiling fan. We have number one is what? It's 2 pieces, 70 watts, 140 watts. We have electric bulb, 10 pieces, 2 Number 3 is television, and number 4 is laptop. Number 3 is television. Number 4 television is 100 watts. Laptop is 70 watts. Sorry, we are looking at the television and the laptop. The television is 4 pieces, and the laptop is 2 pieces. So television is what? 4 pieces. Laptop is what? 2 pieces, which is 100 watts per each television. Then that is 400 watts. Then laptop is 70 watts. That is 140 watts. Now we have number 5, double door fridge. Number 6, medium size freezer. Double door fridge and medium size freezer. Double door fridge. One pieces, 400 watts. Medium size freezer. One pieces, 300 watts. So we now look at the washing machine, which is 2 pieces of washing machine, the dryer and the washing, the dryer machine and the washing machine, and all of them are 260. Washing machine, two pieces. We have 260 watts, which is what? 520 watts. We now have the total. Equals to what? 2000 watts. 6 and 7. So this is the data we have collected. And this data is what we are going to work with. So the client or the customer that called you has this particular information. Probably you might be the one to go and get the information from his or her equipment, or himself told you that this is what I have, this is what I have, this is what he has. So when he give you like that, we can now work with this 2000 watts. But before we move forward to calculate, we use the data to calculate our figures. There are some key points that we need to understand about the power factor and about what all the power factor is all about. Now, power factor in a solar system is the ratio of active power, that is the usable power, usable energy, in kilowatts. And that is why the load we are using here now, for this one now, is giving us the total of what? This is what? 2 kilowatts. So this is the active power now, energy usage, usable energy, that we are going to calculate, for the calculation. We are using it for the calculation. Now, power factor in a solar system is the ratio of active power, that is the usable energy in kilowatts, to apparent power. The apparent power is the rating of the machine, the inverter itself. And that is where what we want to calculate to know now. So the reactive, that is the apparent power, the total supplied power in kVA, that is kilovolt amps, indicating how effectively the solar inverter converts the DC to AC with 1 at maximum being the perfect number of a power factor. 1 is a perfect number of a power factor. And that is why we are using 0.8. Because no machine is 100% efficiency. And for us to have the efficiency, a good efficiency, we need to use the 0.8 or use 0.9 to get what we want. So now, being a perfect, it represents the efficiency of electricity usage, ensuring power is used for useful work rather than to waste it here and there. And that is why we are looking at it. So the value of power factor ranges from 0 to 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then 1. And that is the rating of the power factor and how the power factor is rated. And that is the highest power factor you can have is 1. Now, we want to use 0.8 to calculate in this calculation. So, we are now using 0.8. Therefore, we have read it and show you that power factor is the ratio of active power in kVA, in kilowatts, all over the reactive power, the apparent power in kVA. And now, that shows that I'm cleaning this one now. That shows that we are looking at, we have known our usable energy, which is 2 kVA. And that is what we have gotten from the data we have derived. So, all the same, power factor is equals to what? Active power, kilowatts, all over what? Reactive power, kVA. So this is what we are looking at about the power factor we want to calculate. Now, what is the active power? Active power in kilowatts is actually the true, the real, and the working power that is consumed and converted into a useful energy, like lighting points, the power that carry your televisions and your fridges and your ACs. These are the active power. The unit ranges from watts to megawatts. Watts, 100 watts, 200 watts. Once it reaches 1000 watts, it will now change to kilowatts. From kilowatts to megawatts. So that is the unit that we calculate it. Now, the reactive power in kVA, power that oscillates back and front between the source and the load to maintain a magnetic and electric field in AC circuit without performing a useful work. And that is why it is called the rating power. That's why you see an inverter 1 kVA, 2 kVA, 3 kVA, 5 kVA, 10 kVA, and so on. Because why? It's because it oscillates back and forth. It oscillates back and forth. So now, since you have gotten what is power factor, that our power factor is 0.8, and we have known what is our active power in kilowatts, that is 2 kilowatts. Then from there now, we can be able to calculate the reactive power, which is our size of the inverter we are looking at. That is the size of the inverter we are looking at. So from here now, you see that our power factor our power factor is equal to what? The reactive power equals to 0.8. Now the active power is equal to what? 2000 watts. Reactive power is equal to what? So meaning that this is what we are looking for. That means you have to make this the subject of the formula. Making the reactive power the subject of the formula, you have power factor is equal to active power times reactive now, meaning that you need to have this in question, you cross multiply. Cross multiply. When you cross multiply, you have this is over 1. That means you have what? Active power is equal to what? Power factor times what? Reactive power. So at this point now, you can make the reactive power the subject of the formula. You can now make the reactive power the subject of the formula by dividing both sides by what? By power factor. If you divide both sides by power factor, you realize that you have active power divided by what? Power factor is equal to what? Power factor times reactive power over what? Power factor. So this power factor carry away this, cancel this power factor. So once the power factor carry the power factor in the other side, the reactive power will be left alone. So the reactive power in kVA is equal to what? Active power over what? Power factor. On this note, you can now put the figures. At this point now, you can put in the figures. So the reactive power, the kVA now is equal to what? This our active power is 2000 watts all over what? 0.8 as our power factor. Do you see how we narrow it down? So divided by it, it gives you 0.8. So by the time you divide this 2000 by 0.8, it gives you what? 2500 watts. It will give you 2500 500 watts. So do you see how simple it is? Therefore, to get the exact inverter that will carry the load, because at this point now, you have the total load you have is what? 2 kilowatts. Now, for you now to size the inverter based on this power factor, the efficiency of the machine that you want to build, there is a tolerance that we needed to add to it. And you cannot just do anyhow tolerance because it's an electronics, it's not a generator. Therefore, what you need to do at this point is to add 40% or 50% or 30% as a tolerance in your calculation. So now, but for the sake of this calculation now, we want to add 40% of the kVA we have calculated. So this 2,500, we want to calculate the 40% of it. At this point, this goes with this and this goes with this. That is to say, we have what? 0.4 times what? 0.4 times 2,500. If 0.4 times 2,500, which it will give us what? Which it will give us what? 1,000. So we have 1,000 as the 40%. Now, you are expected now to add this 1,000 to the original size of the machine. $2,500 plus 1,000 is equals to 3,500. Equals to 3,500. Therefore, the size of the inverter needed is equals to what? 3.5 kVA. Do you see how simple it is? That means the size of the inverter we needed is what? 3.5 kVA to carry the 2,000 watts load. With this, the tolerance has been considered, the power factor has been put in place, and it gives you the real thing that you will not be disappointed. That is why you have this tolerance. So by the time you load it, perfectly it will correct. Thank you for watching. If you like this video, don't forget to subscribe to get our next video.